Hi, so I am Harakin from Tokyo. Welcome back, everyone, to the BlinkOn Lightning Talk session. Yesterday, I used this one. Today, I have a more powerful one. This is 7 times more expensive than this one. All right, so let's try. So 3, 2, 1. Yay! All right, so Lightning Talks. I asked all the speakers to insert one point where they can get a storm of applause. So please find the point and send a round of applause to the speaker over the screen. The speaker is also watching this Lightning Talk session. So please use the text chat and send a heartwarming message and emoji to the speaker. All right, let's get started.
Hello, I'm Liviu Tinta, and I'm going to talk about disabling double tap to zoom for mobile optimized sites. Double tap to zoom is a magnification gesture used to zoom into text. It requires a 300 millisecond tap delay to detect double tap. In Chrome 32, this tap delay was removed for mobile optimized sites using a viewport tag like this one. As an example, I have a video with the left tap delay. On the left, the tap delay is enabled. On the right, the tap delay is disabled. So we can see the difference in user interaction. The problem was that the tap delay was removed when zooming was not allowed or when the content width fit the viewport width. So what happens if the content width doesn't fit the viewport width? Then even with a mobile viewport tag, the tap delay is still there. The approach we took was to remove the tap delay regardless of content width when the viewport tag sets initial scale bigger or equal to 1, meaning that the developer expects the site to be readable at that initial scale, or specifies width equals device width. This fix would also disable double tap delay. It will disable double tap to zoom for viewport tags like below. In summary, with our fix, a mobile viewport tag removes tap delay regardless of content width. This fix launches in M91, and we expect to see improvement in Web Vitals first input delay. We plan to run some experiments and gather some data. Thank you.
Hi, my name is Rob Flack from the Chrome team, and today I'd like to talk to you about scroll to anything. One of the fundamental properties of the web is that it's linkable. However, sometimes the content you want to share is far down a long page. Scroll to text fragment launched in M80, allowing links to scroll to and highlight arbitrary text found within the document. The spec adds a fragment directive delimited with a : and allows specifying a range of text to find in the page. Since then, we've seen the feature grow to be used in 0.14% of page loads. Today, most of those links come from search. However, with the new copy link to text feature, we expect organic links to grow in use. So scroll to text works great for text content, but what if I want to share an image, for example, this image? I could link to nearby text, but there may not be any unique text nearby. And if the text is unrelated to the image, it would be at minimum confusing and possibly break if the layout changes. We propose extending the fragment directive to be able to link to some of these. Let's take a look at an example. So building on the same fragment directive as before, we specify the use of a CSS selector and pass the value, which is specifically the selector to use to find the element we're interested in scrolling to. This is building on the web annotation specification, which is a proven powerful syntax and will allow interoperating seamlessly with those web annotations. We've prototyped this by building a Chrome extension. As you can see here, we have this image in the Google image search result. If we click on the image, we then scroll immediately to where the image is on the target page. This saves us having to scroll down the page to find where the image was actually used. However, we have to be careful. If evil.com is embedded by good.com, it can tell when the user scrolls away using APIs like Intersection Observer. This means if evil.com can get the user to click on a link containing a fragment directive, it could detect if the target exists on the page by observing how quickly the user scrolls there. In this case, telling if John Smith is one of this person's friends. To try to mitigate this, we've limited the expressiveness of the selector and are looking into other options for limiting the ability to observe the scroll. Please reach out if you have other ideas. You can learn more about this proposal and get in touch on the YCG GitHub repo. Try it out with the linked extension, and feel free to reach out to us if you want to talk about this feature. Thanks.
Hi, I'm Adrian from the Chrome Platform Security team, and I want to talk to you about C++ Rust interop. Why? We find that about 70% of our security bugs are memory safety bugs, use after free, buffer overflow, things like that. We want to get them under control. For 10 years we've had a super successful policy of site isolation, multiple processes and sandboxing. We can continue to expand that, and we should, but at some point you get to having a storage process per origin, a GPU process per origin, a network process per origin. That doesn't scale, it'll make Chrome slower. We can make C++ safer, but that's going to involve runtime checks, array bounds checks, object lifetime checks, initializing data. Again, it makes C++ slower. So we think in the future, for the most performance critical areas of code, we're going to need to adopt Rust to get static compile time safety with no runtime overhead, or some other future language that could occupy that niche. There's a high bar to include a new language in Chrome. One part of that is good interop with C++, so we've been working on that in a project called AutoCXX. So let's give a quick demo of this. Here's an existing Rust executable that just prints hello world. You can see the output at the bottom of the screen. We're going to modify it to include an existing C++ Chromium API. At the moment it's allow list based. We may be able to change that in future, and we're having to specify a safety policy, which I can talk more about later as well. But after you've done that stuff, it's really super simple. So let's create an origin. And you can just call methods on that. So let's get that running, and then I'll talk about a few things. You can see we've actually got auto-completion and type annotations in the Rust IDE based on what it's been found in the C++. You can see that all C++ objects are owned as unique putters from Rust to avoid any confusions with heaps. You can see that we have to convert C++ strings explicitly to a Rust string and decide what to do with any UTF-8 problems, because Rust strings are always UTF-8. But once you've done that, there's really no particular overhead, there's no particular inconvenience or lack of ergonomics. And there you go. At the bottom you can see it's printed out the URL. That's it.
Hi there, I'm Catti-Schmidt from Microsoft, and today I'll be talking about GridNG. GridNG is CSS Grid in LayoutNG, and you might be wondering, what is CSS Grid and what is LayoutNG? CSS Grid is very similar to CSS Flexbox with modern CSS features like FR units, except it's two-dimensional, and so you have row and columns, which they refer to as tracks. CSS Grid very closely matches the design terminology for grid layouts, and grid layouts are very important in graphic design. They're used all over the place. CSS Grid has a very little dependency on the DOM, but it's very powerful with CSS, so these row and column definitions, or tracks, are defined entirely in CSS, and so this allows you to do things like adjusting the order and the sizing and the placement of all the grid items within the grid, all from just one or two CSS properties. CSS Grid also supports some very powerful CSS keywords and track definitions, which, if you remember, were the row and column definitions, so things like FR units, like Flexbox has, but also some unique things to grid, like min-max, fit content, max content. LayoutNG is the new layout engine in Blink. You may have heard of this in other BlinkOn talks. You're all using this today because most web content rendered by Blink is currently using LayoutNG. GridNG was a major rewrite of CSS Grid in LayoutNG. We have better performance by nature of LayoutNG. We have more WPT tests passing with GridNG, and the rewrite also allows for some upcoming improvements. We have over 30 WPT tests passing that fail in Legacy Grid. We also have some improvements in the data structures used. We use compressed track structures, which I'll talk a bit about in the next slide. We were also able to eliminate the cache for baseline alignment. This was a common source of bugs in the old Grid implementation. We also support some more modern CSS features and track sizing. Repeated track compression is really interesting. The grid syntax allows you to ask tracks to repeat. And so in this case, we have 1,000 rows of 100 pixels and 1,000 columns of 100 pixels. And so the legacy Blink grid would expand these out upon style definition. And so you'd end up with a 1,000 element array in each dimension, which is just, for this case, this massive, massive amount of memory. But for GridNG, we actually store the number of repeats in the track definitions. And so we only have a 1 element array for each dimension here. So where are we with GridNG? We have over 100 CLs in Garrett. You can see the query there for all of the GridNG changes we've made. We're currently failing about 50 tests of the over 1,000 Grid web tests, and we're planning on enabling CSS Grid by default for all users this quarter. So what's next for CSS Grid? Enabled by default, like I just mentioned. Subgrid support is coming soon, and then the Compat 2021 push is a real effort to make test cases interoperable between the browsers so we can get the implementations interoperable. And so GridNG has been a big part of that. We've updated some tests and made some changes there to make things a lot cleaner. So I want to say thank you to everyone involved in GridNG. There are a lot of people involved from both Microsoft and Google. And thank you for watching this talk.
Hi, my name is Adenilson Cavalcanti, and this is znews, the pursuit of hashiness. zlib is used pretty much everywhere. And we're going to be talking about the hashing function used by zlib. From TechP, a good hash must be very fast and should minimize collisions. The type of hash used by zlib is a division hash. It looks like this. I had a question, where did it come from? The first tip came from the TDCB, where it mentioned that the hash came from Unix compressed program. And in 1985, Compress 4.0 was released, and this is what the source code looks. It's really cool that they even mention a comment to Donald Knuth's book and how it compares to zlib's hash. In 2013, Jim Kukunas suggested use of the CRC32 instruction for speeding up compression. In 2018, I implemented that for Chromium zlib. And today, both for Intel and ARM will use CRC32 instruction for hashing. It's really fast, takes just 2 cycles, and yielded a compression gain of 24 to 30%. But TechP also mentioned multiplicative hash as a better option, and Hans Weinborg suggests to have a look on Brutalist hash. And Noel Gordon shared a new hash called ANZAC. But it shouldn't work because CRC32 takes 2 cycles and say multiply add takes 4 cycles. Well, but Donald Knuth said that a good hash should also minimize collisions. And the result was really interesting. Basically, it seems that we could improve between 27% to 30% the compression speed on what we shipped today on Chromium zlib. The compression rate loss was minimal, 0.1%, and since that a multiplicative hash can beat a hardware accelerated CRC32 hash. So basically what comes next is to collect more data, testing, plotting the data, select the best hash. And it turns out that Donald Knuth was right. Not necessarily because something is trendy, that means there's something good. So that's it. Thanks for your time.
So this is jbroman in the case of the time traveling scope draft pointer. So I was working on a unit test recently, and this function here was actually returning null, but PictureReady as a whole was managing to return a non-null value, even though we never took a pointer or a reference to this local variable. Somehow run until idle is managing to retrospectively change the return value from PictureReady no run until idle. Well, how's this happening? Well, in picture ready no run until idle, it turns out there's undefined behavior. So there's a local variable here, frame, which we end up returning, but we take its address and store it in this pointer that gets stored in this mock callback here. That pointer gets written to after this function returns, after the end of the variable scope. So that's undefined behavior in C++. Even though this looks like a stack UAF, it actually passes ASAN and works as the programmer intended. So on Linux x86-64, scope-to-ref pointer has a non-trivial ABI, meaning that when we return it, we actually have to have the caller allocate space on the stack, pass in a pointer and a register and a hidden argument, and then the callee writes there in order to return. So we prepare the arguments for picture ready. We call picture ready, and picture ready is calling picture ready no run until idle. Now it doesn't have to allocate space on the stack because it unconditionally returns the variable that it gets from picture ready no run until idle. So it can just use the same value of RDI and call through into picture ready no run until idle. When picture ready no run until idle then takes the address, we store that away. It returns. We call run until idle, and at some point during run until idle, that value gets overwritten. We return, and we actually get the correct value, even though we executed undefined behavior. The problem arose when I changed scope ref pointer to be passed in registers, a trivial ABI, which saves about 150 kilobytes of Android APK size. That means that we're going to pass this in registers, so we don't need to do that stack allocation. We call picture ready. Picture ready calls picture ready no run until idle. Now, because we take the address here, we actually do need to spill it onto the stack so that it exists in memory. So we take the pointer to there and store it away. In order to return, we copy from that memory into RAX. So we return the value null. Now we spill it onto the stack because RAX could get clobbered. We call run until idle. And in run until idle, we end up corrupting memory because we try to write to that pointer, which no longer points to the stack frame that it was supposed to. So how do we fix this? We fix this by changing the unit test to explicitly take a pointer in a stack frame where it is going to outlive all the writes to that pointer, passing that pointer as an explicit argument to picture ready no run until idle. And when we do this, we prepare the arguments for picture ready. Picture ready allocates that variable in the stack in order to take its pointer. It calls into picture ready no run until idle, which stores that pointer away. And now in run until idle, we're able to write through to that pointer. That's now valid, defined behavior. We return. We copy that value to RAX because we're returning through registers, and we call the caller program complete successfully.
Hi, I'm Asami, working on Chrome browser in the Google Tokyo's office. I'm gonna talk about dedicated workers that will be a service workers client. The browser currently supports 3 types of web workers. In this talk, I'm gonna talk about dedicated workers and the service workers. Dedicated workers execute a single script of the main thread. It can distribute tasks so that they do not interfere with user interactions on the main thread. If you have a heavy task you want to execute in the browser, using dedicated workers is a good option. A new dedicated worker is created by the worker constructor. Service workers essentially act as proxy servers between web applications, the browser, and the network. They intercept network requests coming from pages and other workers. The scope can select which pages and workers should be controlled by the service worker, and it's specified when a service worker is registered. The term of client represents an executable context controlled by a service worker. Dedicated workers, shared workers, or Windows can be a client. Service workers can get all clients via clients.matchAll API. Also, they can intercept HTTP requests coming from clients by registering a fetch event handler. Let's assume an example case. We have a single page, a dedicated worker, and a service worker. The service worker controls the page, which means the page lives in scope. And then the page creates a dedicated worker by calling the worker constructor. In this case, both the page and the dedicated worker are clients. Also, HTTP requests are intercepted by the service worker. Let's assume another example case. The basic structure is the same as the previous page. The service worker controls the page, which means the page lives in scope. However, the page creates a dedicated worker which lives out of scope. In this case, dedicated worker should not be a client. Also, HTTP requests coming from the worker should not be intercepted by the service worker. However, unfortunately, Chromium does not work as expected in the previous case. HTTP requests coming from a dedicated worker might be intercepted even though it lives out of scope. Also, Chromium does not expose dedicated worker via client's APIs. We are now fixing this behavior. Thank you for listening.
Hi, my name is Thomas Steiner, and today I want to talk about file-related APIs in Project Fugu. This is Excalidraw, an application that makes your drawings look hand-drawn. I can open files with the File Open dialog. How this works is based on the window Show Open File Picker API. Up next, I want to show saving files. I want to first make some edits to an existing file, and then save them. And as a proof, clear the canvas and then open the file again so you can see everything is saved and back. For saving, I can either pass an already existing file handle or get a new one from the window.showSaveFilePicker method. This method takes a suggested name and the types as the arguments and then allows me to save to the actual file. I can then get a writable stream from the file handle and write back the actual contents of the file. If I have an existing file handle but discard it, I can implement save as. Next, I want to talk about the File System Access API and how it integrates with drag and drop. I can get a file handle from the data transfer item by calling getAsFileSystemHandle. The File Handling API allows me to integrate with the file manager of the operating system. I can double-click a file or just right-click it and then open with the existing registered file handler, which is the Excalidraw application. This works by first registering the file handler in the web application manifest. This then puts the file on the launch queue of the window, and I can set a consumer that then allows me to deal with the launch parameters and obtain the actual file. Lastly, I want to talk about the Storage Foundation API that allows me to deal with highly performant primitives. One of the use cases for this API could be to distribute a WASM module for WebSQL. You can request a file from the Storage Foundation and then get the requested capacity and then write and read from the file using buffers. These were the file-related APIs in Project Fugu. Thank you very much for watching.
Hi, I'm Richard. I'm the component lead for Chromium at ARM. We're working on enhancing Chromium for the next version of the ARM architecture, ARM v9. Here's what we're up to. Our team's mission is to ensure that ARM is the best platform for browsing the web, and security is an incredibly important part of that. Since we launched ARM v8 in 2011, we've made lots of security improvements. This work continues with PAC, BTI, and MTE shipping soon in ARM v9 devices featuring the Matterhorn and Makalu cores. ARM v9 is a superset of ARM v8. It'll start off as the high-end version and will gradually become the most common form of the architecture. Some features will be backported. However, we can depend on more new and existing features when targeting ARM v9, so it's a good opportunity to improve performance and reduce our technical debt. Let's dive into the first major area, control flow. Control flow attacks chain fragments of benign code in order to do something insecure, like break out of the sandbox. PAC authenticates return pointers to prevent return-oriented programming attacks. BTI prevents control flow from jumping to unexpected places. Together, PAC and BTI are very effective at stopping these kind of attacks and are important for other features like MTE. We've made steady progress since our last update. V8, the Android NDK, and some key libraries like Boring SSL now support PAC and BTI. We're still looking at all of Chromium's libraries and troubleshooting issues on old Android versions. Switching to compiler RT and the libunwine should improve this. Deployment Dragon reckons we should be shipping in the next year or so. Moving on to memory safety. Today, memory safety in Chrome is done mostly through compiler instrumentation, Clang's address sanitizer, and at runtime with things like GWP-ASAN and OilPan. There's increasing interest in rewriting more of Chromium in memory-safe languages like Rust and WAFs, but it'll take many years to convert a meaningful amount of the current C and C++ code base. To better secure this large amount of existing code, we've developed the memory tagging extension, which allows software to tell the hardware about what it's doing with memory. Under MTE, memory can now have one of 16 tags mirrored in the top byte of the pointer. Each time a pointer is used, the hardware can check that what's encoded matches what should be there. If we free a pointer, we can retag the associated area. This implicitly invalidates any remaining pointers. Attempting to use one of them will result in a crash. This means that we can find and fix more use after free areas earlier in development, in cluster fuzz, and potentially in production on end-user devices, making the browser safer for everybody. We're focusing on fuzzing and development use cases first. We've already landed some key supporting patches to help us test the feature whilst it's in development. We're doing a lot of work with the Chrome memory team to teach the petition allocator about this technology. Deployment Dinosaur reckons that we're on track to ship in 2022. There's a lot more to cover on these technologies. We've done a previous talk on some of these features. Links in the deck. Feel free to email us or ask us questions on Slack. But for now, thanks for listening, and have a great BlinkOn.
Hello, my name is Nicky Yamane. I work for Igalia. I'm part of the Chromium team working on adding native support for Wayland on Chromium. This talk is about tab dragging. Basically, tab dragging has been one of the most challenging tasks we've done so far in this effort. So the idea here is to understand why, what we did to overcome these issues, and these current stages. Just a recap. Chromium provides a rich and smooth interface to dealing with tabs. Tabs can be rearranged under tab strips. They can be dragged out into new browser windows and dragged around the workspace and snapped back into other browser windows or drop it in some random location. In order to implement all this, there are a few different layers involved. Chrome UI, where components such as tab drag controller lives, they rely on the Chrome's UI framework, where there are mostly platform-independent components that deal with the whole UI implementation. They delegate platform-specific bits to the platform layer, which in this case is implemented under the ozone abstraction layer. So in order to implement window dragging, for example, these components rely mostly on support from the underlying platform for global screen coordinates, which is fine on X11, for example, on Windows and most of the platforms. But that's not true on Wayland, so we had a problem here. So we had to overcome this, and we used basically the drag and drop protocol that provides most of the functionalities we needed, but it still lacks some features that we needed to implement the full experience of tab dragging. So we had to implement a brand new protocol extension to fill these gaps. This extension was then designed and implemented on Exosphere Wayland Compositor. It's used nowadays by Lacrosse browser. It was proposed upstream, but it's still under review. Its core functionality is to make it possible to anchor top-level surface as a drag icon. But different from the standard drag icon, we can seamlessly transition to a full browser window when the drag finishes. As for the future, we need to continue this upstreaming effort and support other major Wayland compositors. So contributions are really welcome here. So that's it. Thank you. Bye.
Hi, my name is Liviu Tinta, and I'm going to talk about AuxClick ContextMenu as pointer events. What are pointer events? Pointer events are designed to create a single DOM event model to handle pointing input devices such as mouse, pen stylus, or touch. The mouse events have similar pointer events. So for mouse move, we have pointer move, for mouse down, pointer down, etc. And the pointer event inherits from the mouse event. The pointer event interface inherits from mouse event. The discussion to switch click AuxClick context menu from mouse event to pointer event started in July 2016 in pointer events working group. And it was found that pointer ID, pointer type are the most important pointer event attributes to easily identify the pointing device for click, AuxClick, and context menu. The fractional coordinates for these events have been identified as the highest risk. In terms of spec, mouse event is defined as having fractional coordinates, and pointer event inherits from mouse event. However, all modern browsers expose mouse event coordinates as integers and pointer event coordinates as fractional. As per the discussion in the pointer event working group, we decided to experiment with click, AuxClick, context menu as pointer event with fractional coordinates. In June 2019, Chrome Experimental has click, AuxClick, context menu as pointer events with fractional coordinates. In September 2020, we start a Finch experiment in Canary, and we slowly increased the scope of the experiment to 50% stable in April 2021. Up until 10% of stable, there were very few issues. The main concern was reported as the equality comparison between the mouse down event coordinates and the click event coordinates. In April 2021, we increased the scope of the experiment to 50% stable. And in just 2 weeks, we received comments about negative impact on all the releases of ESRI software and APIs. So we stopped the experiment. In summary, click, AuxClick, context menu will remain pointer events. However, we will expose only integer coordinates for these events. The launch is scheduled for M92. Thank you.
To the lightning talk for CanvasKit. In a nutshell, CanvasKit is an open source graphics library for the web. It's implemented in WebAssembly, but presents a JavaScript API. And there are links below with overview information. CanvasKit fits into a page just like any other Canvas element. In fact, the library sits on top of some Canvas element that you create in your website. We created CanvasKit to present a lot of the additional graphics features that are not found in Canvas 2D. 4x4 transforms for perspective, full control over color spaces, custom shaders that you write, layer effects, etc., and a full text shaper. We built it originally just as a playground, but now we see that it's a great tool for us to experiment with new web API ideas. In addition, we use it to host other experiments, programmatic PDF generation, a native body movement player, an SVG viewer, etc. Additionally, the Flutter team has chosen CanvasKit as a way to deploy their apps on the web. If you want to learn more, please visit our site and attend the breakout session called Introduction to CanvasKit. See you at BlinkOn.
Hello, my name is Reilly and I'm a software engineer on the Chrome team. We recently shipped Web Serial and I'd like to talk about an extra bit of work I did to make the API easier for developers. JavaScript is a dynamically typed language. As you can see in this example, having a missing parameter to a function call throws a type error, which is only noticed at runtime. Developers are adopting tools like TypeScript because it can help catch these kinds of errors before the code is deployed. Type information also helps when writing code because it makes your IDE's autocomplete feature more powerful. The TypeScript compiler understands the basic APIs available in browsers, but what happens when we ship a new web platform API? If you tried compiling this code that uses the Web Serial API, the compiler would quickly complain that it calls functions which don't exist. We can write type annotations like this to declare new interfaces that the compiler can assume exist when our code is running. There are some tools which can do this automatically from WebIDL, but in this case, I wrote them by hand. The definitely typed project provides packages which augment the set of JavaScript APIs that the TypeScript compiler natively understands. It's easy to submit a pull request adding type definitions for a new package. In this case, even though the API is provided by the browser and not a JavaScript library, they treat it the same way. My submission was reviewed very quickly, and the project's built infrastructure automatically generated a package and uploaded it to NPM. Now, if we install this package, the compiler will warn us that there is a missing argument when we try to call this function. When building a new API, it is helpful to start with a polyfill. In the case of the Web Serial API, this was particularly useful because the polyfill can be used to support the API on platforms like Android that can't support it natively. Once we have TypeScript annotations for the expected API, we can tell the compiler that our polyfill implements those types. In our case, one feature of the API that the polyfill doesn't implement yet is events when devices are connected and disconnected. The compiler points out the differences between the expected interface and our library. Thank you for attending the Lightning Talks. If you're interested in learning more about the Web Serial API, here are some links to get started.
Hi, so that's it for today. So thank you very much. So please send a round of applause to all the speakers again. All right, so finish. So tomorrow we will have a special guest speaker in the end. So please don't miss it. So see you tomorrow at 3:30 p.m. PST. So thank you very much for joining.
Hi, everyone. Thank you to all the awesome Lightning Talk speakers today. We just have a couple of announcements. The first is a couple of links that you should keep in mind. If you want to check the recordings, you can view them on YouTube, and we'll be adding the recordings as they come in to the schedule. So you'll also be able to go back and check the schedule in the future to get links into the recordings. If we do finish out a schedule, as we have been a couple of times today and yesterday as well, it does mean that there's just more mingling time. And finally, for those of you celebrating today, happy Eid al-Fitr. Time for the sessions.